Hello everyone. In this video, I will show how to calculate the losses in a magnetic gear in 2D analysis. First, we need to understand that the losses come from two parts. One is from the permanent magnets. The other one is from the core materials. First, we need to do some settings under edit effects. We need to enable the edit effects for all the permanent magnets, the inner magnets, and the outer magnets. Then the losses in the magnets will be calculated. Then we also need to make sure that the net current flowing into and out of the magnets will be zero. This will give us more accurate losses results in 2D. We don't need to do this in 3D. We need to assign excitation current and just put value 0 here, so you can see under the excitation there are a lot of zero current coming out of the magnets. Also, we need to enable the core loss calculation for the core materials. We can see under here the defined in material, there is a check for all the core materials, so we just need to check them under the core loss setting for all the core materials. And last one is the outer iron. Then we can run the transient analysis. If we run it, we can see the loss plots here. The first one is the core loss. This is the loss from the laminations. And the other one is called the solid loss. This is a eddy current loss from the permanent magnets. So the total value is 934 watts. So this loss is for all of the outer and the inner magnets. If we want to look at some inner magnets loss, we can use the calculator. So we just need to choose the time, for example the last time step, and we want to look at the total loss of the inner magnet. So we can choose, there are 4 pieces of inner magnet, we can choose one of them and then do the integrate over the surface of the magnet, and then we can get the value of the loss. We need to be aware that this loss value is based on 1 meter. So if your model length is not 1 meter, you need to change it. Another way to calculate the inner loss for the magnets and outer loss is just only allow the eddy current for the inner magnets. In this example, only the inner magnets has the eddy effect, not for the outer magnets. And also make sure that the excitation, that we only put 0 current for the inner magnets. And in this way we can look at the solid loss again. This is the losses for the inner magnets, 350. We can do the same thing for the outer magnets. Here we do not enable eddy effects for the inner magnets, but for the outer magnets only. And also make sure these excitations are only for the outer magnets, not for the inner magnets. Then if we run the transient analysis and look at the solid loss, now it's 580. So if we plus 580 with the previous value 350, it's about 930, which is the total loss that we see here for the both inner and outer magnets. And in some cases, if the rotor is rotating at a very high speed, we will need to add a sleeve outside of the magnets to make sure that the magnets will not fly away into the air gap. So in this case, I added a very thin sleeve here. The material I chose titanium. So how to calculate the loss for this sleeve? Same thing, we need to go to the excitation eddy effect, because in this case this titanium sleeve is a solid piece, so there will be eddy current loss. So we need to make sure that we check the eddy effect for this sleeve. Then we can calculate the loss again. If we look at the solid loss, now instead of 930, it is increased to 1100, because there will be some losses in the sleeve as well. Again, if we want to look at the loss on the sleeve, we can use the field calculator. First, choose the last time step. We can look at the total loss of the sleeve. Now, for example, if the length of the model is 1 meter, the loss in the sleeve will be 208 watts. So this video covers the loss calculation in 2D analysis. Thanks for watching.